I just want to take you through the rundown of the program. I don't know if it can be projected, but we shall have an opening prayer from Patricia Gidai. Is Patricia around? Oh, thank you. Then, of course, after that, we shall have the national anthems being played. Of course, the East African anthem and the national anthem. Then we shall delve into the program of the day. We shall get the opening remarks from the director of PRC or his representative. My request is that we populate for the optics. It would be good if we populate these middle columns first. Sorry. Maybe I have our ushers to just advise those who are coming in so that we populate this one. Then after the presentation or the opening remarks or welcoming remarks by the director PRC, we shall have remarks in this order. We have Engineer Samuel Ogege, who was actually the project coordinator and engineer for the project, the immediate project coordinator. He actually delivered the project until the immediate project coordinator. He actually delivered the project until its full completion. Then we'll have the JICA representative also making a remark. Then we shall have remarks or speech by the director of maintenance, represented by Director Engineer Makori. Then after that, we shall invite the Director General to also do his remarks, after which we shall go into the presentation. And our presentation and topic today is basically slope and bridge maintenance, especially for the MPAD projects. But I believe that the manuals that are going to be launched today will also be very useful in the maintenance of many other slopes in this country and also many other bridges which we are doing. As you appreciate, the country is actually getting very many bridges, not just crossing the water channels, but including those bridges that we are also using as grade separated junctions or the interchanges, as you call them. And so without much ado, I want to request Madam Patricia Gidai that we all be upstanding as
All right, let's bow our heads for a word of prayer. To Heavenly Father, we thank you for this day that you've allowed us to convene in this knowledge sharing meeting. And Lord, we thank you first and foremost for the challenges that we face in our infrastructure development. And we also thank you for the knowledge and the skills that you've enabled us to be able to deal with these challenges. So today, as we share on the knowledge and development, Lord, we pray that our mind will be present and that it will be beneficial to all of us, and that we will come out of this meeting with something good for the people of Kenya. What I've not prayed for, may the Holy Spirit intercede for us in heaven. Amen.
Let's just keep on standing. I think we shall be led through the two anthems.
Afrika Mashariki, tuwezeshe kuishi kwa amani, tutimize na malengo yetu. Jumuiya yetu sote tuilinde, tuajibike, tuimarike. Umoja wetu ni nguzo yetu, idumu jumuiya. jumuiya yetu.
I'd wish to recognize the teams that have actually helped us come this far. We have the support of the JICA, represented here by the JICA Kenya office. Can we just wave to us, the representative of JICA? Can we clap for them? Because this has been immense. I don't know why, Dr. Mogere, you did not raise your hand, because you have been very instrumental in this. Yes. Of course, we have the consultants, Katahira Engineers and Uniconsult and the other teams. Can you raise your hand so that we just see you? Thank you so much. We appreciate the many hours you did this. We also have the KENHA, the KENHA Directorate of Development, the JICA team at KENHA. Can I just see you, those who are here? Thank you. Of course, putting this function together, I know the KENHA JICA team were working very closely with the Department of Structures, who are domiciled at HDS. So the Structures Department here, can we also see you by show of hands? And the Directorate of Maintenance participated very actively. So the Directorate of Maintenance herein, can we also see those who are present? Thank you so much. And of course, putting up all this together and ensuring that we even have this very colorful session is by none other than the Directorate of Planning, Research and Compliance. The Directorate of PRC. And the Bible has a very nice story that somebody organized for a function and nobody appeared. And you know, it is very intriguing. They say at the end, they went in the byways to collect everybody. Yeah, but we also want to appreciate all of us for coming. Can we give ourselves a round of applause? Yeah. Because if we only came, only those of us then who are engaged in the project, then perhaps it would not have been this colorful. And we also recognize the teams or the members who are with us virtually. Project coordinator and engineer for the project, the immediate project coordinator, he actually delivered the project until
training in slope protection and inspection of long-span bridges. These trainings were facilitated with the support of JICA and the lead expert of Manchin Expressway, my dear friend Nishi-san and Dr. Kawakami-san. As Engineer Karot has rightly said, the trainings that culminated in the production of this manual was not only confined to this project, it not only confined to the Directorate of Development, not only confined to Kenya, but we extended these trainings to Kenya Railways, Kenya Airport Authority, Kenya Maritime Authority, anybody in the vicinity of this project that was interacting with this project were involved with this training. And this training, the purpose was to produce a pool of trainers that would in turn continue training other younger engineers and inspectors so that this knowledge can be extended beyond the project into all other pieces of infrastructure that experience the same kind of challenges. This manual therefore represents an important milestone in ensuring that the long-term safety, resilience, and sustainability of this strategic piece of infrastructure is ensured. Dogokundu bypass, as you all know, is a critical corridor that enhances connectivity and facilitates trade and supports economic growth. And therefore, the corridor interacts with the airport, it interacts with the standard gauge railway, it interacts with the old railway line, it interacts with our seaport, Itevu, and also the new port that is envisaged at Dogokundu and the special economic zone. And so to protect this valuable investment, effective maintenance is essential. The training that culminated into this manual provided practical guidance that will strengthen inspection, monitoring, and maintenance practices, helping to extend the surface of slopes and bridges while ensuring safety, not only of road users, but also of our crew, the inspectors, the inspection team. The inspections are done in very difficult terrain, and therefore necessitating the use of modern facilities. We are using drones to ensure the safety of our crew who face tricky environments. And not only so, when we started this, when we started the training, we were only confining it to maintenance experts. But the site proved very tricky, particularly in terms of geology, and therefore it was necessary to vary this contract so that we would bring in geological experts so that the sinkholes and the cracks that we were encountering would receive much better expert analysis to ensure that the maintenance treatment that we are giving them was holistic. I therefore wish to sincerely express my appreciation to JICA for their support and continued partnership, the technical expertise they availed to us, the support in developing the piece of infrastructure and also developing this document. This collaboration demonstrates the value of international cooperation in strengthening infrastructure management and capacity development. Ladies and gentlemen, as we launch this manual today, let us remain committed to applying its recommendations. As I said, we have a pool of trained trainers that we should be using going forward to build technical capacity, continue promoting a culture of preventing maintenance, and by so doing we will safeguard infrastructure assets and maximize the benefits they provide to our community and the nation. I want to encourage that this document should not be kept somewhere in a safe and gathered dust. Let them be a tool that will ensure that we maintain the deep slopes that we encounter across the country and the long span bridges that we are building going forward in a manner that is safe, not only for the users, but also for our staff. With that, I want to end there. Thank you, and I wish you a successful launch and a fruitful discussion. Thank you and God bless you.
Thank you, Engineer Ogege, for taking us the memory lane on how these documents or the journey to generating these documents. I want to take this opportunity to ask the JICA representative to also come to the podium and make his comments. Welcome, Maurice.
Good morning. The Director General Representative, Engineer Gakuru, directors of various directorates, distinguished members present, government ministries, consultants, engineers, members of academia, ladies and gentlemen. My name is Maurice Mwangi. I'm a program officer, Infrastructure Department, and I have the honor of delivering these remarks on behalf of our chief representative of Japan International Cooperation Agency, Mr. Shinkawa Makoto. It is a privilege to join you today at this knowledge sharing forum on slope stabilization and bridge maintenance under the Mombasa Port Area Road Development Project. On behalf of JICA, I'd like to express our sincere appreciation to KENHA, the project teams, engineers, and all participants for making this important forum possible. JICA highly values platforms such as this that bring together professionals and stakeholders to exchange experiences, lessons learned, and technical knowledge. While infrastructure as we know it often emphasizes on the construction phase, we recognize that sustainable infrastructure requires much more than building roads and bridges. It requires continuous investment in technical assistance, maintenance, resilience, asset management, and human capacity development to ensure that this infrastructure continues to serve communities and economies for generations. Ladies and gentlemen, as you are aware, Japan and Kenya share a long-standing partnership which is built on mutual trust and a shared vision for sustainable development. Over the years, JICA has supported Kenya's efforts across key sectors, including transport, urban planning, water, energy, etc. And all these are guided by Kenya's national development priorities, including Vision 2030. Within this partnership, Mombasa occupies a unique strategic position as Kenya's port city and gateway to East and Central Africa. The efficiency of Mombasa's transport as a city has implications not only for Kenya, but also for neighboring countries which are served by the Northern Corridor and depend on the port for access to international markets. It is within this broad vision that the MPAD project, now more commonly referred to as Mombasa Southern Bypass, was conceived. This project has made a significant contribution towards decongesting the port, the Likoni Ferry Channel, and providing alternative transport routes to the mainland south and providing an access to the most important economic hub, which is the Mombasa Special Economic Zone in Dongo Kundu. Ladies and gentlemen, today's forum should remind us that infrastructure does not end when construction is completed. The long-term value of these investments depend on how effectively they are maintained and protected. Slope stabilization measures and bridge maintenance will help safeguard public investment, enhance road safety, disruptions, and ensure reliability in transport services. By exchanging experiences and discussing challenges today, we'll learn the best practices, we'll strengthen our collective ability to manage infrastructure assets more effectively and sustainably. In closing, allow me to reaffirm JICA's commitment to to supporting Kenya's development journey and to strengthen our partnership with the government of Kenya and all stakeholders represented here today. Thank you very much for your attention, and I wish you an insightful discussion. Asanteni.
Thank you so much. I think your last comment of this presentation, we are also going to have another knowledge sharing forum where our independent design verification consultant is also going to present his findings on the upcoming Mombasa Gate. So we are here to stay with JICA, and we thank you so much for the cooperation. Without much ado, allow me to welcome my dear friend and colleague, Engineer Makori, who is going to give the speech on behalf of the Director Maintenance.
The Director Maintenance, Engineer Ezekiel Fuko, who unfortunately was not able to be with us today. So I'll try and stick to the script as presented. So the Director General, the development partners, consultants, engineers, technical experts, colleagues, ladies and gentlemen, good morning. It's a great honor to join you today during the 9th edition of the Kenya Quarterly Knowledge Sharing Forum here at Barabara Plaza Auditorium. Today's forum marks the launch of two important documents, namely the Slope Maintenance Manual and the Bridge Maintenance Manual, developed under the Mombasa Port Area Road Development Project, commonly known as Dogo Kundu. From the maintenance perspective, the real value of infrastructure is not seen only at the point of construction or commissioning. It is seen over time through safe, reliable, sustainable service to the road users. A corridor may appear complete on the day of commissioning, yet its real value on performance is proven over the years of service. The maintenance is a discipline that carries the initial investment safely through its design life, preserving the standard of service to the public and the level of service that the public was promised. Once a road or a bridge or even slope protection system fails, then there's a problem in terms of a reduced level of service or even the design life. This is why maintenance must remain central to Kenya's mandate of managing, developing, rehabilitating, maintaining of national trunk roads. Maintenance is what crosses the life cycle, and without it, engineering gains achieved at huge capital cost can be eroded within a very short time. This forum aligns with the Kenya Strategic Plan of 2023 to 2027, particularly the focus on road asset management. Our responsibility is not only to build infrastructure, but also to preserve its value, reduce life cycle cost, and ensure that the public investment continues to serve the people of Kenya. Every sharing that is directed to timely planned maintenance protects far larger costs already committed at the construction stage and sustains the corridor that are vital economic arteries, moving goods from the port of Mombasa to markets across the country. The Dogo Kundu bypass has provided valuable lessons for maintenance practice. The corridor has experienced slope-related challenges such as sinkholes, gyre formation, seepage, clogged drainage, damage to slope protection, and landslide incidents. Many of these defects emerged within the early years of service along the steep cut slopes in variable and sometimes unpredictable conditions. They remind us that vulnerability on such terrain is structural rather than incidental, and therefore must be anticipated and managed from the outset. This experience also underscores that roads are living assets. They are affected by geology, water movement, traffic loading, human activity, weather patterns, and climate conditions. On the ground, maintenance teams deal with changing weather, drainage failures, vandalism, aging assets, traffic pressure, limited resources, and defects that may not always be visible during routine inspection. For instance, a blocked drain may lead to erosion. A small crack may develop into a major failure. A missing drainage component may compromise the entire slope protection system. These factors rarely act in isolation. They compound one another so that a single deferred defect can quietly progress into a costly emergency. The lesson is that small, early actions prevent large, expensive failures in the long run. This is why we must continue moving from reactive maintenance to proactive, risk-based whole life cycle asset management. One of the key lessons from Dongo Kundu is that drainage is a first line of defense in road asset preservation. Once drainage fails, slope protection becomes vulnerable. Water begins to move where it shouldn't. Soil weakens, erosion accelerates, and failure becomes more likely. The mechanism is well understood. When slopes become saturated, the soil loses shear strength and pore water pressure rises, both of which drive instability, while concentrated and uncontrolled flows score away the very material that holds the slope together. Managing water is therefore not a secondary task. It is the foundation of slope and bridge stability. For this reason, the manuals place strong emphasis on routine inspection, drainage clearance, early identification of defects, proper recording, timely intervention. We must address the issue of damage and loss of drainage components. Where drainage systems are vandalized, blocked, or poorly functioning. The result is not just a maintenance problem. It becomes a risk to public safety, asset performance, and public investment. The manuals therefore provide a practical guidance on strengthening maintenance responses, including the use of more resilient drainage solutions in vulnerable areas, supported by proper outlets to ensure that water is safely discharged away from the slope. This includes careful placement of outlets, measures to dissipate energy of fast-flowing water, and discharge points located well clear of the slope toe and the bridge foundations, so that water can be led away safely rather than be allowed to undermine the very structures they are trying to protect. The value of these manuals is that they convert field experience to standard operating procedures. For instance, the slope manual, the slope maintenance manual guides teams on inspection, monitoring, routine maintenance, and repair of slope protection systems. It helps the team set inspection frequency according to the risk and the season. And they recognize and classify defects consistently and know when a condition has crossed the threshold that calls for intervention rather than continued observation. On the other hand, the bridge maintenance manual provides a structured approach to bridge inspection, condition assessment, preventive maintenance, and performance monitoring. For bridges, attention must be given to critical elements such as the deck drainage, expansion joints, bearings, crack and corrosion, score and erosion near foundations, bridge approach settlement, and condition rating and reporting. Together, these two manuals will support safer infrastructure, better planning, consistent reporting, improved use of maintenance resources, and reduced long-term repairs to our infrastructure. Colleagues, good maintenance is built on discipline and consistency. It is not enough to identify a defect. We must inspect, record, act, and follow up. These steps form a continuous cycle rather than isolated tasks. Each inspection generates a record, each record informs the next decision, and each action is verified by follow-up that comes after it. Despite this kind Discipline of this kind is what separates maintenance that merely reacts from maintenance that genuinely protects. Our team must consistently patrol the corridors, inspect our slopes, clear all clog drainage, manage the overgrown vegetation, remove all debris from our drains, document all the defects early enough, and also be able to enter the inspection data into a system that supports monitoring and decision making. This is how we can move from the isolated maintenance action to a structured and data-driven maintenance culture. Reliable records allow us to track the assets over time, identify recurring problems, prioritize work that matters most, and justify the resources and budgets that our teams require. Safety must remain central. Slope maintenance is not an ordinary work. It requires proper access, supervision, and protective equipment, as well as safe working methods. Working on steep slopes and at a height introduces hazards that are not present in ordinary roadworks. Every such activity should be preceded by a clear method statement and a risk assessment before the team can mobilize to sites. No maintenance intervention should expose the staff, contractors, and road users to avoidable danger. Safety and quality reinforce one another. A job that is properly planned, well supervised, and carried out safely in most cases is always the job that is done thoroughly and to the right standard. Training and capacity building will also be critical in making these manuals effective. The on-the-job training conducted on 1st and 2nd of December 2025 at Dongokundu Slopes was a good starting point. It combined site observation, drilling, lectures, and discussions. Pairing classroom learning with hands-on practice in this way is the most effective means of transferring skills, sustaining it. Will help build an internal cadre of staff who can apply these manuals confidently and mentor others across the regions. Such training should continue across teams so that the manuals are not treated as shelf documents, but as practical tools for daily maintenance work. As we launch these manuals, my call to all regions, project teams, consultants, engineers, maintenance personnel is clear. Adopt these manuals, use them, make them part of our maintenance culture. Let us carry out early inspection. Let us record findings accurately. Let us also clear drainage regularly. Let us intervene on time to protect our bridges and slopes from premature failure. In that way, then we're able to embrace data-driven, evidence-based decision-making approach in asset management. The success of these manuals will not be measured by their publication alone. It will be measured by safer slopes, better bridges, fewer emergency repairs, robust records, and faster response of our teams to achieve resilient load assets. Allow me to recognize the leadership of the chairperson and the board of directors, the director general, our development partners, consultants, technical experts, regional teams, engineers, and all Kenya staff present. I also acknowledge the EMPAD team, project team, the Directorate of Development, the Directorate of Planning, Research and Compliance, and the maintenance staff and the consultants who supported the preparation of these manuals. Your contribution has helped turn field lessons into practical guidance that can improve how we manage and protect our road assets. These manuals are a product of genuine collaboration, and they now belong to all of us as a shared institutional asset to be used, refined, and improved over time. I encourage all participants to engage actively and share practical ideas on how these manuals can be implemented across our road network. The challenges we face at Dongokundu are not unique to that particular corridor, and the experience captured here can guide maintenance on similar terrains elsewhere. I will encourage our regions to exchange what works so that today's launch becomes a starting point rather than an end point. Let us ensure that these manuals move beyond our shelves into every inspection, every maintenance plan, every site decision, and every response action. With those remarks, I wish you fruitful deliberation. Asanteni sana. Those are the remarks of the Director, Maintenance, Engineer Ezekiel Fuku. Thank you.
Thank you very much. Can we give him another round of applause? That was loaded, right? That was loaded. Were you listening? Yes. Too many technical details, and that is the reason we are here. Maybe sometimes this issue of maintenance, maybe Dr. Mogere, you'll have to tell us sometime. You know, the African concept of maintenance was eroded when somebody came with this issue that we are building permanent houses. Yes. When I remember a young man, our house was mud-walled and grass-thatched. And you find every year there was a touch on the roof, on the walls, on the floor. Then somebody said, this is too much work. What you are now doing is what? We are doing permanent. And then the word permanency deleted the concept of what? Of maintenance. I think that is where we need to recalibrate, because while as we think it is permanent, other people are continuously maintaining the permanent. And so it is important, as Director Maintenance has indicated, that we do not just take the books. I just wanted to say that in our engagement with the JICA team, we said what we need also to include is a bit of reflecting back from planning to design to construction to maintenance. So the manuals may be called maintenance, but they actually also cast a shadow from planning phase all the way to maintenance. So I want to take this opportunity to invite you to interact with the manuals and ensure that you don't think it is for Directorate of Maintenance. It is very important for planning, it is very important for development, and is also very important for maintenance. Without much ado, I want to invite my director, Engineer Gakuru. I'm inviting you as director. I know you are representing the DG. When you now finally go to the DG, you invite yourself. Because I can't invite the DG when you are here. So allow me to take this opportunity to invite the Director Development, who is also the representative of the DG, to also give his remarks and set the session rolling. Director, welcome.
Yeah, good morning, everyone. Yeah, my name is Engineer Andre Gakuru. I'm the Director of Development in Kenya. First of all, I want to appreciate the presence of every one of you, and to recognize the presence of JICA, the presence of the consultant, that is Katahira and Uniconsult, the presence of our staff, Kenya, and I hope we are represented in all the directorates. And also our sister authorities. We had invitation, and I hope they are all also present with us. I want to appreciate also the people who are virtual, who are online, participating in this important knowledge sharing meeting, and also an occasion where we will be launching the manuals. I would like to say that we have had quite some journey with JICA and the government of Japan, in that from the time Kenya gained independence, you look at the history of engagement of JICA with development in Kenya, you find immediately after independence they started working together with us and helping us in building capacity in our infrastructure, and they were very much prominent in bridges. You look at the bridges that are in Kenya and you find all of them, if not all, majority of the bridges in Kenya were in one way or the other achieved through the support from the government of Japan. There has always been a lot of capacity enhancement, and trainings have been conducted overseas. I am one of those who have benefited from the training from support of JICA that happened in Japan, and I'm very sure majority of the engineers in Kenya have gone through the same program. So I'm trying to say that we have gone a journey and we are continuing. And the future will also depend on the relationship that we have had with JICA. It is through that cooperation that we have been able to gain quite significantly. And this is only one of evidences of the gains that we have had. We have had manuals, it has been mentioned here before, manuals on management of our projects, manuals on cost estimates. It's quite a long list, and here we are adding to the list. We are having manuals for maintenance of slopes and also bridges. Coming fast forward, we have had the development of the MPAD project, which has quite some significant part of it is a bridge or structures. And therefore, these manuals are coming at the right time, that where we are heading to, we need to do proper maintenance of our structures, because they are becoming heavy investments in our infrastructure. We are soon going to have the Mombasa Gate Bridge. It will be a major structure, not only in Kenya, but probably in Africa. And therefore, we will require to have proper preparations for maintenance of those structures. I would want to not say so much. I had requested that my speech be combined with that of the Director General. My speech has not been combined, but I will have some additionals when we get to the speech of the Director General. So I wish to stop there, but I appreciate that we are all here. Thank you very much. So, Engineer Karot, I think I'll have to say more when it comes to the Director General's speech. Thank you.
Thank you. Thank you. Thank you, Director. And now is the time we've been waiting for. We are going to have the presentations by our two experts, Dr. Yoriko Kawakami. Just relax first. I have to introduce you well. Yes. Yeah, Dr. Yoriko Kawakami. I think we have interacted with Dr. Yoriko Kawakami until sometimes I almost call her Mukami. Many times. She's going to give us a presentation on the bridge maintenance, and this is a brief of who Dr. Kawakami is. She is a bridge maintenance specialist and international road asset management expert. Dr. Kawakami is a distinguished civil engineer and a bridge maintenance specialist from Japan with over 30 years experience in the highway infrastructure management. Her expertise spans bridge maintenance, road asset management, post-disaster restoration, and international technical cooperation. Throughout her career at Hanshin Expressway and related organizations, she has led strategic initiatives in maintenance planning, asset management systems, outsourced maintenance supervision, and international business development. Dr. Kawakami is widely recognized for her technical proficiency in the bridge deterioration assessment, life cycle cost analysis, and the development and implementation of bridge maintenance systems. She has played a key role in advancing maintenance standards, promoting contract-based maintenance approaches, promoting performance contract-based maintenance approaches, and strengthening institutional capacity for road authorities in both developed and emerging economies. Her international experiences include long-term engagement in Africa and Asia, where she has contributed to the design and delivery of capacity building programs and advisory services. Notably, she served as a JICA technical expert, supporting the enhancement of the outsourced road maintenance through improved contract management, supervision tools, and contract evaluation system. She holds a PhD in civil engineering from Kansai University, Japan, a Master of Science in Civil Engineering from University of Colorado in USA, and both bachelor's and master's degrees in civil engineering from Kinki University in Japan. Her contributions extend across Japan, Kenya, Thailand, Morocco, and Cambodia, where she continues to promote sustainable, efficient, and accountable infrastructure maintenance practices. Can we put our hands together for Dr. Kawakami? That is, I don't know whether that is a CV or a resume. I'll need to be advised. You know, there is a difference between a CV. I think that's a resume. Then we have Motohiko Nishibayashi, aka Nishi. He is a road maintenance and asset management specialist. Motohiko Nishibayashi is a senior civil engineer and international road asset management expert with nearly 40 years experience in the expressway planning, maintenance, and infrastructure development. He has built a distinguished career leading in modernization initiatives in road maintenance, life cycle cost optimization, and performance-based maintenance systems with extensive experience in both Japan and international settings. Throughout his career, Engineer Nishibayashi has demonstrated strong expertise in urban expressway management, bridge asset management, long-term maintenance planning, construction supervision, and contract management. He has played a pivotal role in advancing efficient, accountable, and sustainable infrastructure management practices while supporting institutional capacity development for road authorities across diverse regions. His international experience spans Africa and Asia, including significant contributions to the technical cooperation projects in Kenya, the Philippines, Morocco, Thailand, Cambodia, Ethiopia, and Laos. As a chief advisor to the JICA Road Maintenance Management Project in Kenya, he led initiatives to strengthen outsourced maintenance systems through the development of practical tools for cost estimation, tendering, supervision, and contract management, while also supporting the introduction of the road condition survey systems. Engineer Nishibayashi has also contributed to the major infrastructure projects in Japan, including expressway construction, toll road planning, and the development of bridge management systems aimed at optimizing maintenance, prioritization, and budgeting based on life cycle cost principles. His work in performance-based maintenance planning has helped enhance service delivery, accountability, and cost efficiency in expressway operations. He holds a Master's of Urban Planning, that is Environmental Studies, from the University of Toronto, and a Master of Engineering in Civil Engineering from Kyoto University. Let us put our hands together for our two presenters, Engineer Nishibayashi and Dr. Kawakami. They are coming in to do the presentations, and they will tell us how they will be interchanging. You now need to take your pens and papers and start jotting down notes and even your questions, because it needs to be interactive. Thereafter is when we shall be doing the launch of the two manuals after their presentations. Can we put our hands together for the presenters?
So good morning. On behalf of Empire consultant teams, it's very the privilege to speak about as a teams to doing for the advisory works for the Empire project. We start. Okay. We start with the just the overview of the project of MPART. We don't need to explain a detail about what is the MPART. This is the new bypass project in Mombasa and Kwale County, linking the all kinds of important infrastructure in the counties. Naming a port, airport, the corridors, and the newly coming SEZ. So I understand that how important this road is, and not only the significance of the project, the road itself, but this roads has lots of importance in terms of structures, namely the long span bridge and the slope, vulnerable slopes. So that's why the consultant team not only dealing with the design and constructions and supervision of the construction, but it's the first case in JICA project to added the maintenance components in this funded project by JICA. So we are happily to engage in this project, and also not only the regular maintenance, but also be focusing on the two special structural significance, bridge and slope, to to make a capacity building and talk with a lot with the Kenha engineers, engage with all the practice of the maintenance works, and then they finally put into the manuals. So one is slope. There's very many slopes because of the earthwork is dealing with the cut and fills work. So, and due to the geological condition of these very vulnerable geological conditions, we have to deal with the things dealing with the maintenance is a little bit special consideration should be needed. And then the 3 long span bridges on the road, which is the Muache Bridge and Tunza Viaduct, and then Muteza Bridge, which is the longest bridge in Kenya as of now. And also, there's a lot of structures, like U-turn bay on the way. So, as I say, our consultant works is we have maintenance advisory works, which is the first case. And first of all, we think we don't know how to do it. What is the advising? What should be advising to the Kenha for these new structures? But we decided to focusing on the bridge, long span bridge, which is very unique compared with the ordinary bridge, and also the slope, which has compared with other slopes, that this slope has a very vulnerable and with the special protections, and also the condition of the adjacent structure, which is airport, has a little bit complicated thing, so that we try to do something special technique or the procedures to deal with this slope. But also we collaborate with the other JICA funded projects, which is PBC projects, which is already done, and also this is PBC is now the norm for the routine maintenance in Kenya. So, and also that it's ongoing project on bridge maintenance project, which is done by Fujiwara-san's and other stuff, and now almost finished. So when we started the advisory works, those 2 things are not yet existed. So that but gradually over the period that this two new procedures of maintenance is put in place, which is now exercised a lot. So we collaborate with them, so that the bridge, especially the bridge is already integrated into all the bridge maintenance systems across the Kenya. But we should focusing on the special constellation on long span bridges on the sea. And also the PBC is already put in place in the Mombasa Southern Bypass. So how to integrate it, the PBC contract, to deal with the slope. So we're just focusing on slope, but basically the routine maintenance will be conducted within the PBC scheme. So this is the overview of the project. So now I'm talking about the slope first, which is in the last 5-6 years, we focusing on the slope and how to maintain them, which is is a little bit complicated and difficult issue right now on the slope on the Kipebu Road near the airport. So over the years, we introduced the new technologies of inspections for slope, which is done by drone, and also the how to restore it, the damaged structures and damaged slopes, and how to keep on doing it, and putting in all the practices and all the measures for maintenance and repair into the manuals. So let me switch to the my presentation on slope. Okay. So slope, it's not the ordinary earthwork, which is sometimes very unstable, sometimes, and then when something happens, that's like a landslide or rock falls, the situation is very, very catastrophic and damage a lot on the road. So we're focusing on, but first, what is important things to think about the slope maintenance is about the condition of the soils. So I can explain about the condition of the slope, particularly on the end part. The end part is in Mombasa regions, which is compared with other regions in Kenya, which is relatively young, because of all the sediments is by the accumulation of sand bringing from the sea. So the two major features on these regions, one is Jurassic shale rock. It's a rock, and which is it's 100 million years ago, I think 500 million years ago, there's a shale in Jurassic period, which is there's still the dinosaurs is running around, and so it's a very muddy mud rocks, but very strong. But the problem is there's easy to be fractured. It's a planes and a plane each other. And once it's exposed from the area, it's easily to be weathered and fractures. So this the picture shows that how the condition of this and how weather is. So once exposed, and the easy to be weathered and no strength at all. So that's the conditions. And sometimes you can find in area around the Muache junctions and the beyond to the conjunction to the northern corridor. Another things which is it was just accumulated on the shell is called the Magallanes sands. I never heard about the name. But Magallanes sand is very soft, unstable sand sediments, which is on top of the shell. So you can see, sorry, here, the Magallanes sands. So it's very unstable and easy to be eroded and creating the gullies. The surface water is running and digging the land and making the gullies, and also the easy to be eroded. So that's the area which is unfortunately around the airport areas. So that's the condition given by the design teams. So that's the regular cross sections of the load to deal with. So usually this is the original cross sections. So in order to build these loads here, we have to cut the part of the slope and fill it on those, and then make a flat space, and then make a load with shoulders and drainage systems on both sides, and then there's a slope here. So in order to design, in a design stage, we have several things to be considered in order to where to put the loads. Because the budget is limited, so that we have to minimize the cost as much as possible. So that the point to be considered in design is to balance in the cuts and fills, so that the volumes of the cut section, you can put the soil into the fill sections. So we try to balance it so that no additional soils or no export of the soils to the ground. And then the slope should be fair gradients. So depends on the condition of the slope sections, where the sand should be very stable, like 45 degrees. If there's a rock is very stable, unless no weatherings, so that the slope can be steep with the self-standing. But sometimes due to the limit of our load reserves, which is happening in Kipebu Road, which is because of the airport on the other side, and then the SGRs, and then the mangroves and the coastline is on the other side. So that we should think about the alignment should be on the limited space, so that therefore we try to minimize the slope protections, but somehow we have to protect it for unstable condition to be stable. Then the problem is always the water. The water is coming, and Mombasa is the monsoon area, so that lots of rains. And sometimes it's on the surface, and sometimes it's still underground. The water is always the problems and nuisance for the slope protections. So in the southern bypass, the problem is happening on those two areas. One is Mwachis Junctions, which is connecting to the package 2 to the corridor, and then the area around the airport. Especially the airport area, which is, they look like this. Sorry. So there's a Kipebu Road here. There's slopes, and then on the top of the hills, there is a Moi International Airport here. So the road is here because the SGR is coming here, so that we have to the alignments of the load should be here, but only, between our boundary, load reserve boundary, and to the shoulder, that we have to cut the slopes, but sometimes we have a little bit steeper hills. Then, in order to keep the stability of the slope, we have to put the slope protections. So this is an ordinary cross section of the slope. Usually the 7 meter high, and the gradient is try to be bigger, but in this case the 1.1 by 0.5, which is very steep on the first slope, and then 1.1, 1 by 1 in the second, third, and fourth, and then up to the boundary of between the KAA and the load. So this is the cut area of the load. And then the lead line is more like it's a landslide line. It's expected landslide lines, so that we expect to this line, so that we have to protect it to keep the strength of the slope against the landslide stress. And then, because we try to minimize the slope protection structures, because it's very expensive and very difficult to maintain. But it's inevitable. So that we have in design, we have to choose what kind of proper way of protecting the slope. So in this case, it's a bit too much smaller, but we have a chart depending on the condition of the soils, and also the soils, whether it's a sand or rock, and also the water conditions and so on. All factors are considered to choose the most proper and most reasonable protections. So we have a 4 protection for cut slope and 1 protection for the embankment. So one is the stone masonry, which is the block layer of the protection, which is the strongest protections, so that we use it for the steep structures. Usually on the first layer, first slope, just beside the load, because it's the most important part to protect the load. Then it's gradually we try to reduce the gradients, and then we use the 2 types of structures, which is called lip lap, which is the covered with the stones and connecting each other with cement. Then also the little bit reasonable way is to call the herringbone frame protections. This is the frames, not the concrete, the stone covered, but look like a herringbone, which is a frame construction, frame protections. Just a frame itself, cling each other, and to protect, to support the slope. And also this frame itself uses for the drainage, and also the land area between the frames is for we put the glass to protect. If it is more lower steeps and lower and less gradient slope, we just put the grasses. Grass should be deep rooted, so that the grass itself to grow up naturally, and then protect the land, protect the slope from sliding. The choice of the grass is very important. Should be, again, the deep rooted and indigenous. that we don't want to bring the exotic grasses into Kenya, so that it's a domestic grown. Then, again, when you deal with the shell, Jurassic shell, which is strong enough, but still, once it's exposed, which is very getting weather easily and less strong, so that we spray the concrete. This is the pictures shown on the Moache junctions. This is very steep, more like a 40-meter high, not 40, sorry, 20 to 30-meter high, but just we spray the concrete to protect and not to expose the shell rock from outside. Another important structure for the slope protection is not the protection of the slope itself, but how to deal with the water. Again, the water is a very, very important factor to make the slope weaker, so that the Mombasa is the regions with lots of water, lots of rains falls, so that the slope drainage facilities or slope drainage systems should be carefully done and to be maintained. In a slope, it's more like systematic drainage systems. Not only the lateral drainage, but each slope gather the water and then putting into the one place, and then vertical drainage to put into the catchment, and then through the culverts, and then go into the ocean. So that's the system. But once it's broken in the one section, the water is overflown to jump onto the floor and sometimes damage the structure. This is the one of the lateral drainage system, which is very important just besides the boundary of airport and road, which is called the cut-off drainage, which is actually cut off the water coming from the airport not to going into the slope, to bring it to the vertical drainage, and to properly to bring it to the water going down without overflowing. But even if we properly designed, we properly constructed, of course, the slope is very unstable thing, so that there's lots of failures, and which is sometimes inevitable, which happens a lot in Japan, because Japan is a land of mountains, so there are lots of slopes. We have lots of history of the big failures and catastrophic damages on the road. Several phenomena. Most notorious one is landslides. You can see this. There's a landslide lines that once it's the water is coming down and so much water underground, or massive erosion happens. Once and one trigger make it the whole mass of land going into sliding toward the end. I will show you the one very dramatic video on landslide happening in Japan. See, the road is now closed. So this is a monitoring camera that so huge mass together with the trees falling down. So this is the picture of aftermath. See how massive the landslide is. The important is to show the video itself and how dangerous the slope is, but also for the road authority, why this, you should think why this picture is taken. Because we stopped the traffic beforehand. We know that the landslide is about to happen. So we close it, the traffic, then we monitor it, put in the camera on. Then that dramatic picture or video can be taken. So that's the importance. So of course, there's no casualties, nothing. But the damage is very serious. It takes years to restore it. And in this case, that instead of putting back the soils, that we built the bridge on the landslides. Another thing which is maybe happening in Kenya as well, the mass lock failures, which is happening a lot, and of course catastrophic. And even it's a lock. The lock is weathered over years. Then there's a cracks, and then once there's one single rain falls or anything or earthquake, then the huge mass of rocks falling down from the very high top and to the ground and damage the road. And embankment. The embankment is the fillings of the soils. You need to protect. Compaction is not enough. That the embankment is also causing the landslides. The trigger factors of those kind of failures is many things. In Japan, we have an earthquake, but mainly the rainfalls is the trigger things. Of course, there is a human aspect of like lack of construction failures will be the cause, but mainly is a natural cause. The rainfalls in Kenya is the very biggest factors to trigger this kind of landslides. Then we properly finish the construction, and then the maintenance stage is happening. So unlike the ordinary road, what is the most important things for the slope is stabilities. To keep, nothing happens. The slope itself is standing, and over years, if the rain comes and anything happens, but the slope is still standing, and to still protect the soil from toward the roads, and nothing happens on the road. But it's easy to say than done. The stability over years is getting less stable with so many causes, soil conditions, and the risk causing the things, and some external factors. So, but the change of the slope is sometimes very difficult to see, because the slope is sharp, steep, so that it's easy to access, difficult to access, and also sometimes it's covered with bush, then it can't be seen, and also the many things happening underground. It's invisible. But what we have to do is keep monitoring to check and do the measures preventively, not the countermeasures. That's the important things. Unlike the earthwork, or like, for example, pavement, if you have potholes, then you take actions. But the slope is as long as we think is not to be done. So because it's very difficult to visualize it, and also its speed, the speed of failures is very faster than the others, and because the rain comes every years, and then and also once it happens, the damage is unrepairable, or the damage to the road is so much cost. So then sometimes takes years, and sometimes takes years and months to stop the traffic. That wants to be happen. So that the monitoring is important, and preventive action should be very important. Compare with earthquake or compare with bridge. So keep watching, so that keep watching by authorities, sometimes by the contractors, but also what is important thing, because it's not a problem of the road reserves. It's happening elsewhere because the land is because of the cause origin of the problem is happening elsewhere, and then going down toward the road, so that the collaboration efforts with the adjacent owners. In case of Mombasa, especially the airport, KAA, is important. That's what we are going to do, and together with KAA this time. And also, monitoring, again, is very difficult. Not visual check, because it's very difficult to go to access, and it's hidden, and also something happening beyond the road reserves. So that which is airport is a very secure area, so that we cannot go easily going to the site. So what we are trying to do in Mombasa, especially the Kipebu Road, we introduce the drone. Drone is now the very common technology in Kenya, so that we fly the drone, we're using the very high resolution camera to capture all the image of the area. So not only the road reserves, but also beyond the reserves, that the whole entire region's area can be captured. So this is one of the example of the image. You can see it. This is the road here, and we can capture the airport, which is a little bit difficult in the process of the drone flying, because we need a special permission from KAA. Used to be the no-fly zone for drone, but we got a special permission from KAA when there is no flight, that we can fly the drone to capture everything. The image is very high resolution, so that we can find all kinds of failures which is not visible from the road, and sometimes even if we try to approach it, it's difficult. We can find lots of failures, especially the sinkholes, because of the eroded sands. And then it's lots of sinkholes within the airport, so that this is the failures within the KAA premise, but we can find many potholes in the area, and of course we share this information to the airport authority. Also, this is the high resolution, as also we can get the point clouds data, so that can be converted into not only the image, the flat image, but also 3D image. So you can see this, the gradients. This is the load, this is the airport area. Then we can see how steep the area is. Then we can see lots of sand erosions and happening in all those areas. So that the 3D, we can recreate the 3D image that to be easier to understand the condition of the soils, but also together with the gradients of the slope. But that's the still image. But we can, with the point clouds, with the special application, that we can see more detail about. Then you can switch it. Okay. So this is a special application that the 3D image can be recreated like this kind of. So you can move to any place. Then you can zoom in and zoom out. For example, this is you can see this is the damage area with you can see the erosions, and you can see the damage on the drainage systems, because you can see that the sand is already goes beyond the slope. And also you can goes to the airport area. So this is the patrol loads within the airport. So, but you can see this huge sinkholes happening on the road. Can you zoom in a little bit more? So you can move all the image to go to any place. Then you can go to the other sections, which is you can find the numerous sinkholes happening, which is also within the airport area. Yeah, here. Can you zoom in as much as you can? See, you can see the potholes. So also the whole section, whole area is now sinking. So this is within the airport area, which is inaccessible, but also within the bush, so that it's not visible from anywhere. But the drone can capture it, and you can find it. So this is more like this screening of the whole regions to find out the damage. Then, once you can find the damage, maybe you can go. You should go and to check what is, because sometimes there's some mistakes. The hole is not a hole, its hole should be the shade of the trees. But maybe it's worth seeing it and then these conditions, and then find and try to think about the solution. So using the drone, there's several places which should be checked for this slope sections. Most important thing is not only the road, not on the drainage systems along the road, which is inaccessible, but here, the slope. Drone is the one thing to do it. Then, if you can access, you can go reach to the closer. You can go there as much as you can by then put into the database. I think the picture itself, the photos, of the drone and photo that you go closer to the more detailed detail photos to show the damage, and also the location is most important data, so that they put into the database, which is not necessarily the more like a checklist and just think, but just the data, the photo can tell everything. Then you keep on inspection, and the drone inspection that we conducted in a consultant teams is after rainy seasons, so twice a year. So we do it four times in around June after the rainy season in May and April, and also the January or February after the rainy season in November and December. Because the water rainfalls is the most the trigger, one of the biggest trigger of the causing the damage. Then routine maintenance should be done because of you conduct the PBC. PBC is doing but the PBC is usually mainly focused on the load and up to the drainage system on the shoulder. But what is important for this slope, the slope maintenance, is routine maintenance for the slope up above, which is sometimes missing to check, but important to check. We advise the coast regions to conduct this routine maintenance integrated into the regular routine maintenance, routine PBC works for focusing on slope. One is routine patrol of the slope. Usually that you can climb up to the certain point, so you can go to check the conditions. And if you find some irregularities, you can do some routine maintenance works. One thing is drainage systems. Drainage system is easily to be silted and it's filled, so that the water drainage system that cannot work. So that we just desilted and excavated and put into the normal function. Another thing is especially typical in slope is the trees and bushes, which is sometimes unnecessary. Just the trees or bushes growing from the slope or growing from the drainage systems, which is unnecessary. There is the tree itself is not so the enemy of the maintenance. Sometimes the tree itself is a protection. So that you can choose that what is necessary or unnecessary, but usually clear the unnecessary trees on the slope. And sometimes there's failures on the protections. Sometimes it's falling down like a silt or the fractured concrete cover, which is going down, or the loose rock, which should be removed. It's because it's a loose that any time that is going down toward the road. So back to the Kipebu Road, we conducted the drone. We checked, we evaluate the photos, then check the soil condition from based on the previous geological survey in the construction stage. Then we've tried to find out the cause of the problems. which is we should focusing on the area around the airport, especially the almost 300-meter section in just west part of the shelters sections, which is not yet there's not significant damage toward the road, but we check the drone photos and also this geological surveys, and then it comes any times. The things are some failures is happening right now. The drone image. So this is a very steep, 4 layers. So first, and then all in between there's the berms, so that it's more like 30 meters high. And just above, on the top of the hill, there is a boundary between the boundary of the road reserves, and beyond that there's an airport. There's shown that the soil is moving onto the surface, is covering the slope and going to the reach to the second slope, which is very close to the road. The irregularities are everywhere. The sinkholes that you showed, and in the airport. Also, you can find it in the road reserves, and that caused the damage on the drainage systems, which is the one is very serious one is the failure of cut-off drains on the top, so that the soil is eroded together with the drainage structures, so that it means that all the things are gone. Then there's a sinkhole inside. So that the cut-off drain is supposed to be the water catched not only to the slope, but go toward the vertical drainage, but the water is running toward the water, then together with soils. Another issue is vandalism. The berms. There's the drainage supposedly catch the water moving toward the vertical, bringing the water going to the water, but this concrete structure, reinforced concrete structure, but all due to the vandalism, it's all gone. So it should be so that the functionality of the drainage is all gone. So it means the water is not catched, but go jumping onto the slope. So together with all the information, data, and the previous surveys, and we can try to find out, and also it's confirmed by the geologists, geotechnical experts from Japan, that this is what is happening in this area. So this is a boundary. The water is always falling, and then because of the flat lands of the airport runways, it's the easy place to catch, to bring the water. Supposedly, the water is treated by the airport and not bringing the water going down to the airport, going down to our slopes, but bringing down to elsewhere to properly drain down to the ocean. But because of the damage on the drainage system in airport, also the erosiveness of the soil, because of the Magarini sands, the water is going down to inside the ground very easily everywhere. That makes the sinkholes happening. Sometimes big, sometimes sometimes invisible, but once in the rain, it's getting bigger and many. So it's going down toward the sneaking into the weakest parts of the water, of the sediments of Magarini Sands, and then it's going to reach to our slope. Once it's then that was because of the water pressure going up, and what the soils and water keep providing. Then the one trigger, one rainwater is excessive to the supporting strength of the slope. Then it's splashing out. Then damaging the drainage, damaging the drainage, and damaging the slope protections. And since even if that happens, that if the drainage system of each berms is working, that the water is keep absorbing by the drainage system properly treated toward the ocean, but it's damaged. So what is happening of the soil water? Where it goes onto the slope. Jumping on the slope is now keep accumulating. Then the road is here, and sometimes in the erosion is coming toward and up to this section, is now keep moving toward the going down, and it should be it's now progressing. The drone pictures can tell easily to the relationship with the soil condition in the airport and toward the slopes. So that's the area where there are lots of sinkholes. So that's the section. So the water going down and now spraying out, probably around here, and then now going down. Same thing happens. There's lots of sinkholes, not close to the boundary area, but also near the airport runway. So that's the problems, not only our problems, but also the problems for the airport. So this is the sections that the water is splashing out. So after the water is splashing out, that's galleries, formations, and this is you can see that how the water is now splashing out. And no one can see it. Hope that it's somebody there to go in the rain times, that you can see the phenomena of the water splashing out from the slope. So it's one of the outcome of the drone. Then, especially for the Kipebu Road of this particular section, which should be taken immediate action before something happens on the road, and to prevent the road closure by soil erosions and waters. So we now, the last 6 months, we consult with the coast regions together with the maintenance department to do some emergency actions taken. And they're focusing on this 300 meter section with the numerous cut-hole damage, drainage damage should be recovered, and some protective measures. Let's say those damaged drainage systems should be recovered, and this is a soil erosion, so that we should put some gabions works, gabion installations to protect the soil, prevent the soils and water from soils from the going downward, and then take all the necessary the bush clearance and also debris removal, and Then also the most important thing is the installation of staircase, because we expect that the people going up. So now we can't go up without the rope. So that we try to put the staircase so that the easier for the inspectors or the repair workers to go up. Then mainly we try to repair the drainage system back to the normal condition, like this one in this particular section. And then the water keep coming. That's inevitable, but the water is properly treated toward the ocean. So that's all the works, activities that we have done in the last, I think about 5 or 6 years. So not only that we do some advice works, but also we do some outreaching or capacity building things. So twice we done the maintenance seminars. One in a drone seminar that we introduced drone technology, and one is the routine maintenance seminar trainings together with KENHA, Coast Regions, with the contractor, PVC contractor, to deal with. But finally, at last, the end of our assignment in advisory works, that we summarize it into the manuals, slope manuals. That can be all kinds of informations from the geological survey to the maintenance, including all kinds of technologies used for the inspection and repair works. Then this manual is the products of KENHA, so and also that it's important to share with the other authorities like KAA or the other authority which has similar problems. And also that, of course, this manual is not for MPART. That can be used for the other regions which has similar problems of the slope. So that's the end of my presentations, and then especially the drone, that is the first case, as long as I know, in Kenya to use the actual inspections. It's widely used in any place, because drone technology is available very easily. The only thing is how to use it, how to properly use it. So that thank you for the drone company, which is showing that the 3D image, and then which is, if you necessary to consult, the company is now with us today, so that please free to consult with him. Thank you very much.
I think let's give him another round of applause. You know, if you are instructed in, if I was instructed throughout my university in Luo, and then I have to learn the new language, hasn't he tried, right? Hasn't he tried? And we have had. So it's a time for questions and answers, just to make it as engaging as possible. I want to request that those who have questions or concerns or points of clarification, is now time to raise them. Maybe I'll go column. Any question on this column? Okay, you are still thinking. We can come back. This one, this column, right in front of me. Pass. Yes, director? Is it a roaming mic? Yeah, it's coming.
Thank you very much, Engineer Carrot. And thank you very much, Nishi, for the very good presentation. It's very clear. And one thing I've noted is that the solutions that have been given in that presentation are so specific to that site, but will be very much applicable to many other sites that we have along our roads. My concern is we are aware that there is some work being done by the Airports Authority towards the same protection of the slope along the Kipefu road. Probably what they are doing is within the airport site, but I'm aware there is a contractor doing piles, constructing concrete piles. I don't know to what depth, but there is some work going on that in that site. Mine is to ask if the solutions that we are looking for are also coordinating well with what Kenya Airports Authority is doing, and what impact will that have on what we are proposing for the Kipefu site. Do we need to consider to check whether what they are doing is effective enough, or will it amount to double effort? Thank you.
Thank you. And so it's difficult to answer because the KENHA, KAA, is the very independent authorities. Used to be, we don't know what the KAA is doing, but up to now that we know that we persuade during the course of my advisory works that we always asking the KAA is involved. It's especially thanks for the engineer Ogege to keep asking KAA to participate. So they know that the situation, and also we conduct a joint survey of the area within our side, and also we are allowed to go inside to check this in, and also at the same time we advise them do something, because it's not I'm blaming you, we blaming the KAA, so do something, but we know that they are very concerned about how to, not only how to protect our roads, but how to protect the runway, their facility, because not only the roadside problems, but the erosion happens around all the airport premise. Is now sometimes they say is the second runway is already closed due to the erosions. So that it's not so we try to think this is not our it's not a problem for us to help us to do that, but also to think about it's your problem. So that's why they do some action, they hire the consultant to do some action. But also, from now on, it's very important to communicate each other, to know that what they are doing, and also that KENHA side also asking, keep on informing them what to do for our side. So otherwise, it's more like a brain. Sometimes it's going to be the blaming games, but now the collaboration is now going very well, right? As long as we know, because the first time sometimes KAA is doing itself. It's not a problem for KENHA's problems, but also its own problems, and then doing something to treat the water, to fill the sinkholes, and to do some pilings or whatever I know to deal with. So I think this is a very good cases for collaborations. It's not KENHA's problems, but also the soil it's very wide area. So I think it's beyond my advisory works, but as long as I think KEA is thinking about very carefully, very seriously about about this case. Thank you.
Thank you. Any other question? Yes, engineer. The guy with the roaming mic. Okay, yeah.
Thank you very much. My name is Engineer Mbima Byron. I'm the Directorate of Public-Private Partnerships, also representing the Federation of African Engineering Organizations, Capacity Building Subcommittee. I've followed the presentation very keenly. Thank you very much for the elaborate presentation. There's a video you showed where there's a failure on the embankment. There's a section you showed in your presentation. Maybe you can take us through the intervention measure which was taken so that maybe we can learn from it. The intervention measure taken to address the failure.
I think that was a video showing how being proactive in monitoring our slopes can enable agencies to even manage issues related to traffic, because that particular section was just a video of how they monitor their slopes, especially in Japan, so that they're able to predict and know with this intensity of precipitation and the type of slopes we have and how we have been monitoring, then there is likely to be a slope failure. So that was basically advancing even to us as an agency, that even as we do our inspections, perhaps it would be good to have that continuous monitoring of some of those installations so that we are able to preempt challenges, especially to road users. Because remember, they were able to close the road much before the slope failure occurred. So it was basically advancing as we start in Kenya now, where we are even engaging the drone inspections just to not just monitor the road, but even off our corridor. It is basically indicating to us that this is what we need to do. But when you now come to the issues of interventions, I believe that is what has been given in the maintenance, so that sometimes you can preempt some of those failures by managing even the cut of ditches, by managing the surface irregularities, which brings the sinkholes, by ensuring that we clear the drains, by ensuring that we also even provide proper channels for the water so that not all precipitation goes down but is directed through the drain. That perhaps is because this was specific to this particular MPAT project, but it was just saying how things happen and how they can be captured. Is that okay?
Thank you very much. I stand guided. And I'm also thankful because for the nuggets we've gotten from the presentation will also assist us towards the projects. As you are aware, we are doing the Rironi, Maimaihu Naivasha side. It's on the escarpment side. And these are some of the knowledge we are going to use in the project. Thank you.
Another question from here? Seems here has more questions.
Yeah.
Yes.
My name is Engineer Muruki from Development. On the section you presented near the airport, there was a time we had, initially, there was a failure. Of course, I've seen the interventions, but I wanted to know at what point do we use the sheet piles, and if it was something utilized for that section as a measure of slope protection.
Could you repeat it a little bit? Sorry.
Yeah. Earlier on that section, there was a time there was a failure.
Yes.
So among the interventions I've seen, I think there was also utilization of some piling or
yes.
sheet piles. Maybe you can elaborate more on the use of the piles, those sheet piles.
Okay, the pilings is very comprehensive measure to protect, to strengthen the slopes, so pilings deep into the ground to stop, to do the landslide lines that to protect the lands from slidings. It's already exercised in the, not on the section that we concern, but the other section which has some massive landslides happen during the construction time. Then so the consultant or the contractor do the pilings to prevent. So that's very comprehensive, very effective, but at the same time very expensive. So now the road is open, how to do the pilings on the top of the hills, how to bring the large machines, how to bring the manpowers, how to bring the materials on the top. So I don't want that happens in this particular section, to spend a lot of money and very difficult works. But we asking the KENHA to do something beforehand. So emergency works is very limited repair works. Plus, we're asking them to monitoring by intensify putting into the routine works. The patrolling, again, is very important. So that's why we can prevent that the landslide section I show you in the video in Japan. The section is very prone to the landslide, so that maybe KENHA inspectors or the the road authorities keep monitoring, keep going then, showing that any change in the road, like some cracks or the water things, and then so that's what we asking to do, intensify it. So minimize the interventions, not going to that pilings solutions, but we have so many things to do. So that can be done in the PPC works, and so the water treatment is one thing, and also the bush clearings, and also this minor routine maintenance is one thing you should do first, and then that can be prevent the extensive damage in the future. So that's the maintenance for. Don't think about the things that doing this. But I know that your maintenance budget is limited, so that what we can do, then that's a very important road. That's one of the most important road in Kenya. So that I don't want that things happening and to spend a lot of money and then disrupting the traffic between the port and the elsewhere. So that's the things. So I know that you should think about the pilings or the other comprehensive solution, but that will be the last things to think.
By the time you do piling, you may not be doing maintenance. You may be doing reconstruction of the slopes. Any other question from this side? You seem to be satisfied, right? Was there a brainwave here? Nothing? And then here, okay, there's the mic, please take. And that will be the last question to Nishi before we welcome the next speaker.
Thank you. My name is Moses Opio, Kenyatta University Civil Engineering. Now, mine is not a question as such, but just to say that slope failure is not restricted or confined to road agencies. What I would request JICA is to expand, because every year we get cases of whole villages submerged because of slope failure, especially Muranga and I think Elgeyo Marakwet. So I would request that you expand your mandate, not just to road agencies and KAA, but also to the county governments, because we lose quite a number of people. Thank you.
I think as important things, so I pass your opinions to JICA or the KENHA, how to use these manuals, how to transfer this experience in KENHA to the other authorities, not only the authorities, county governments, and maybe others. The slope, I think the soil issues, slope issue is the omnipresent in Kenya, and I understand that, and I don't want that so many people killed by the landslides and other soil failures every year. So that's a tragedy for the country. So thank you for the very precious opinion.
Thank you so much, Mr. Opio from KU. I think when we were starting, we knew that this was a Kenya project, but very applicable to many other agencies and entities outside Kenya. And our DG is here. I believe he has taken those sentiments and he's going to engage with the other stakeholders. Now, can we put our hands together for Nishi-san? He has done a good job. He is a man of writing, so all those things he has said, they have been condensed into a book. And in the current world, as shall be directed, I believe every one of us here will have a copy of that book once it is finalized and endorsed by the DG and the chair of the board. I want to take this opportunity to recognize the presence of Director PRC. Engineer, thank you so much for coming. We have started. I believe you will have time to make your comments. For now, allow me to welcome Dr. Kawakami to do the presentation on the bridge maintenance. Welcome.
I'm sorry to keep you waiting. Oh, could you help me? Sorry. Oh, yeah, it's coming. Sorry. So, good morning. Habari za asubuhi. Jina langu ni Yoriko Kawakami. So, let me talk in English. So, I'm in charge of the bridge part. So, we developed a bridge maintenance manual for especially the long span bridges in the Mombasa Southern Bypass. And as you know, there's 3 long span bridges in this Mombasa Southern Bypass. Moache Bridge's length is 660 meter, and the Tunza Bridge is 691 meter, and the Muteza Bridge is 1,440 meters. It's longest in Kenya currently. And these 3 bridges are located in here. The Moache and the Tunza, Moache and the Muteza bridge is located in inlet area, and Tunza bridge viaduct located in the intertidal zone of the peninsula. So at first, to do the maintenance, we have to know about the feature of the bridge, especially the design of the bridge is very, understanding the design of the bridge is very important to do the maintenance. So I want to tell about the bridge configuration of each bridge. And this is the typical scenery of left side hand is for Muteza or Moache Bridge, and this is for Tunza Viaduct. And let me talk about the bearings things because these bridges is a continuous girder bridges, and it has this kind of bearings, a set of bearings in the bridge. And do you know that there's 2 types of the bearing, the move bearing and the fixed bearing? And the fixed bearing is that absorbs the rotation of the superstructure, and it takes vertical loads and acts on horizontal forces. So it doesn't allow the horizontal movement, but rotation. Fixed bearing can absorb the rotation. And the move bearing can absorb both rotation and also horizontal movement. And this is the typical section of the Moache or Muteza Bridge, and this shows the 7-span continuous bridges section. So in the both ends there's a move bearing, and for the center pier they have the fixed bearing. And so on the move bearing, there's a expansion joint here. But all the same type of the rubber bearing is installed here, like this. So it can support the vertical load and with the horizontal movement in all direction, and rotate all around. So, but for the fixed bearing, fixed part, the horizontal movement is fixed by the anchor bar on the center pier of the continuous girder. So this shows the drawing of the part of the Moache Bridge, the girder, and also the pier, like that. So just a moment. So this bridge is designed based on the British standard, BS standard, together with the AASHTO and Japanese specifications. And the superstructure consists of span length of 40 meter and 10 meter in height for clearance of the vessel navigation. So not only all the span is not 40 meters. Some span over the for the vessel navigation, the span is 40 meter, and the other span is 30 meter. And for the substructure, considering the constant water depths of both bridge between 5 to 10 meter, so the depth of the water is 5 to 10 meter. So for the substructure piers, so in this Moachi and Muteza bridge, pile vented substructure substructure is adopted. Pile vented substructure is to raise foundation piles to the ground level and connecting the heads of each pile with reinforced concrete beams to form piers. So this structure can reduce the number of the temporary works required for footing construction, thereby shortening the construction period and reducing construction costs significantly. And this feature of the steel piles, the design life is 120 years based on the BS code. And the corrosion speed is considered in the design based on the Japanese port-related design specifications. And the corrosion allowance means that corrosion considered in the design of the steel pipe is 36 millimeter for above sea level, above seabed, and 3.6 millimeter for below seabed section. And considering the corrosion in the above seabed section, using the steel pipe pile structure is uneconomical. So, reinforced concrete structure is adopted for design, but steel pipe is continuously used from the seabed as a cast in situ concrete formwork. This shows the moment diagram for steel pipe, steel pile pipe. And you can see this is the seabed, riverbed, and this is the water here, and it is underground. And this is the moment diagram for, this is for, I remember this Moachi and Muteza, like that. And you can see that the range on which the bending moment act is limited. So we have to have the strong structure only here, and it doesn't have to be stronger like this for other portion. So in here, this is the structure. So this lead part should be very strong, and if it is only it is the steel pipe, we needed the 25 millimeter thickness of the pile, but it can be less than 19 millimeter by filling the steel pipe with the concrete at the maximum bending moment action. So this part is correspond here. So it has very thick steel pile with a concrete inside. And this part is very strong. And under here, it doesn't thick like this. So it lessens to 16 millimeter. And the concrete is not inside. And this over the water, and it is thickness is 60 meter, and concrete is inside. And above here, to consider about the corrosion, the thickness have to be more than 36 millimeter, but it is not economical. So in the design, it was considered as built as the concrete pier here, not a steel pipe. But for the construction work, this steel pipe was extended on the top until the beam. Then that steel pipe can be worked as the framework, but still the concrete it is inside. And this is exposed to the water on the water, so it is painted with epoxy resin and covered. And for the pile, the concrete is filled, so we want to fix firmly. So this kind of steel tube structure was adopted. So this steel pipe, it has the inner ribs inside. There's a rib inside. So when we put the concrete inside, it can fix it properly. And this is the Japanese original product specified in the Japanese industrial standard JIS. And this is the picture of constructing the steel pile pipe. And for the Tsunda viaduct, the uniform steel pipe were driven from the pile foundation to the top of the beam. So the structures are a little bit different, and this all the way from the bottom to the top, it's a uniform steel pipe here. But on the ground, it is covered with concrete. So if you see the Tsunda viaduct, you think that you feel like this is a concrete pier, but the inside is still a pipe, and it is covered with concrete. And the next, for some section, soft ground consideration was needed because this is the location of the Mache Bridge, and this is the original design. And actually, in the initial design, after crossing the Mache Bridge, it was designed as all the viaduct throughout, like 1.3 meter of the viaduct here. But finally, the Tsunda Bridge starts like here, and length is 600 or something. But so between this Mache Bridge and the Tsunda viaduct, there's a very ground is very soft, but the height was not so high, and for the economical reason, it was changed to embankment from the viaduct. But the 4 meter of the embankment was applied, but this ground is very soft because this is the tidal, intertidal area. So the settlement was worried. So it was examined. So between Moache Bridge and the Tunda Bridge, this kind of 4-meter embankment was investigated. And you can see that this is the N value. N value is an indicator to show the softness of the ground. And if this value is very small, like this is the N value is 0, it means that the ground is very soft. And you can see that there's a lot of depth of the ground has the N number of 0 something. So it means that the ground will be sunk if you put a road in the long term. And this is the calculation result due to the 4-meter of the embankment. And this is the settlement from the initial ground, and this is the time. And you can see it is some location of the boring, core boring of the ground. And you can see that 30 meters in, say, 50 years or more. But most of the settlement occurs soon after the construction. So it is the kind of elastic settlement. And after that, consolidated settlement occurs. So the 2 years or more is already passed after the construction. So already this settlement is occurred, and we predict the maximally 28.3 centimeter is remaining. It's for NF2. NF2 is the blue line, this one. So residual settlement is predicted as 28.3 centimeter. And in Japan, we have the standard of this kind of settlement allowance of the soft ground, and it is said like allowance is 30 centimeter. So it is less than allowance of the settlement of the specification in Japan. So we consider that there is no special treatment is needed for this settlement. But problem might occur in the bridge approach section, because this is it shows this is end of the Moache Bridge, and this is the heading for Tunda Bridge, and this part is there's a 4-meter embankment. So say if the ground sunk in uniformly, it's okay, but in the connection of the approach section, abutment doesn't sunk, but this on the ground approach section will be sunk. So there will be the gap in the future. So to avoid that, this kind of box culvert was set here to reduce the weight of the ground, so that we can avoid the gap between the abutment and ground section. And this kind of thing is already happened in package 1. Package 1 was open earlier than package 2, and a couple of years before package 1 was open. And there's one bridge named Ago Bridge. And in the same manner, the approach section was sunk like this. This is the actual measurement of the settlement by time, 2018, 2019, 2020. So this is the start of the service, and in the 1 year, 66 centimeter settlement occurred like this. So overlay was conducted by the contractor during the DNP. But after after 1 year, the 10 centimeter more 10 centimeter sunk. So they applied the second overlay. But so far, the settlement is already stable. So they need two times overlay. So in this package 2 section was learned from this case and do the treatment like set the box girder, box structure in the beginning and avoid this kind of situation. So for the superstructure, and I want to explain about the bearing. For the Moachi Bridge and Muteza Bridge, there's a kind of special bearing is installed, and it's called pot bearing. And this is the shape, outlook of the bearing. So the rubber is inside this kind of the rubber plate is inside of the upper shoe and lower shoe and can rotate any direction like this. And the upper shoe and lower shoe is metal structure, but it is covered with special high durable coating because it is over the sea. So it is more durable compared with the ordinary paint. So for the maintenance, the metal bearing is tend to have this kind of damage due to the water. It is sometimes it is easy to get a corrosion like this. So we have to monitor this kind of situation by inspection. But anyway, for this bridge, it is already adopted the high durable painted bearing. So maybe it is the fewer consideration for the corrosion compared with the ordinary one. For the Tunda viaduct, it apply the pad bearing. Pad bearing is like it's have the rubber bearing, rubber plate with the steel plate inside like this. And this one is also used high durable rubber material. So this is the typical damage of the rubber bearing because the rubber is very affected by the ozone and easily gets the crack on the surface. But in this bridge, the material is very high durable material is used. So this is the usual case that have the crack or abnormal compressive deflection. But maybe this bridge uses the high quality bearing, so it might be a fewer concern about this kind of damage. But anyway, do the inspection is very important. And for the joint structure, there's two types of the structure, two types of the joint, and there's a finger type and angle type, because the movement of the girder is different. So the span of the Moachi and Muteza bridge is longer than Tunda bridge. So the Moachi bridge and Muteza bridge pier section, the joint on the Moachi and Muteza Bridge pier is bigger, movement is bigger. But Tsunza Bridge apartment and pier, and also Moachi and Muteza Bridge apartment has smaller movement. And so that for here, the angle type joint is used. And I forgot to explain, but for the bearing, it is the product of Kawakin. It is a Japanese manufacturer of this kind of things. And the joint is also the product of Kawakin Corporation. And they name KA joint and KFC joint. So KFC joint is the finger joint. So the main material is cast iron with excellent weather resistance. So the main body is integrated with a finger and anchorage parts. So let me show this one. Usually, this kind of finger face and plate is connected with welding, but if so, there's a problem of fatigue. Fatigue problem is occurs, but this is the cast iron, so it is constructed in a one time. The finger plate in the finger surface is the integrated structure, so we don't have to worry about the fatigue problem. And also, the cast iron is very durable, like that. And also, there's a elastic strip seal under the finger. So, and this material is also strong and durable, so it can sustain the sand or kind of debris is if that kind of thing is push this part. But this part is very strong and can protect the bridge. The main part of the bridge, like this. And this is for the anchor type. Sorry, angle type bridge. And the feature of this joint is it's for the small movement, and it has a simple and durable design using the commercial steel plates for easy manufacture. And so yes, it is the feature of this joint. And this, in here, in the M part, the very sophisticated street lighting system is adopted, installed. So get a battery from the solar system, and there's a gateway device on here, and connected online. And also there's a QR code on the pier or in the battery here, and there's a ID of each this street light is installed in this QR code. So if you read this code, you can understand the ID code of each lighting poles. And and it used the remote monitoring system for operating the street light. And for us, I'm sorry that I don't understand how to read, but I think it is the French forche or something. But this is the name of the manufacturer of this kind of street lighting system. And they use this kind of, they called LoRa. LoRa is the abbreviation of the low data radio wireless. So radio wireless system connects to the gateway from each lighting pole. And then this gateway sends the data to the server with the internet. And then in the office, you can get the data from the server like this. So you can observe the situation or operation of the lighting system by this kind of remote system. For the maintenance, okay. So as a beginning, I told that this bridge is very unique. So in the maintenance, we have to think about based on the design, which part is important to monitor or maintain. And for this bridge, it is very unique, multi-span continuous structure with fixed support on the middle piers and movable support at the both ends of the girder. And movable support connections have expansion joints to secure the calculated gap to accommodate the expansion and contraction margin of the girders. Then if the gap clogged with dust or other debris, the girder movement is hindered and the entire bridge system may not be worked as considered in the design. So therefore, periodical inspection and debris clearance, so cleaning of the joint is very important. And bearing is the most important but vulnerable component in the bridge. So close visual inspection and partial defect treatment are necessary. So as I mentioned that there's a move bearing in the end, and there's a joint here, and for here there's a same time of the bearing. So maybe the most important part is monitoring here. Here also the joint have to be functional. So cleaning of the joint is also important, and we have to check if the bearing is functional. And there's the various way to monitor the bridge. And for the close visual inspection, we can use the bridge inspection vehicle. Kenha also have this vehicle, and also the boat can be used. And also every end of the continuous girder, there's a inspection corridor is set. So this kind of things, this one is also can be used. So there's inspections are classified into three: daily, routine, and principle. And actually, this framework is proposed in JICA bridge maintenance technical cooperation project. So we also follow this way of thinking. And daily is the PBC. So PBC contractor is in charge of this one. So the methodology is patrol, and if something abnormal, they will inform to road authority. And the routine is, this is the same as the inspection system of KENHA. I think you have ARBIX. So it is same as ARBIX to do. Even this is a special long span bridge, but the routine inspection is conducted same as the ARBIX system. And it is to think, I'm not quite sure who conduct this one, but I heard, I remember that it is conducted by road authority engineers, and once in a year they will do the remote visual inspection. So, and then next is the principal inspection, and this is the more detailed inspection and to assess the soundness of the bridges. And I think KENHA will outsource this inspection, and it is proposed to conduct every 5 years. But for the MPAD bridges, these three bridges is just recently constructed. So maybe, of course, you can do the principal inspection after 5 years, the opening. But maybe at first, this bridge is constructed in very high quality. So I think you can extend the duration to do the next inspection. The initial inspection was conducted soon after the completion of the bridge, but you can think about when you have to do the next inspection, like you can extend to next 10 years or something by monitoring the bridge. So anyway, you will do the ARBIX every year. So you can consider when you do the next principal inspection from the result of the ARBIX routine inspection. So the PBC, this shows the standard service level in the guidebook, and I think there's a description in the contract between the PBC contractor, but the standard is like this. And for example, bridge expansion joint, the service level is all the expansion joint must be clean and in the good condition. So in the contract of the PBC, this kind of thing is written. So the contractor have to keep the expansion joint anytime in good condition. And this is the typical damages of the expansion joint. it's not visible, but this is the water leakage due to the damage of the expansion joint. And also there's a clogging of the expansion joint. And due to the clogging, there's a chip, the damage of the finger joint like this. So this kind of situation is have to be solved soon. And for the routine inspection, and this is what to do in ARBICS. And for the surface, it is simply using the corridor. Pedestrian corridor is set in these 3 bridges. So using the corridor, you can check the surface of the bridge. And for the girder or substruct piers, the important part is around the abutment or around the pier. So if you can access easily this area, like using the ladder, I want you to access as much as possible like this and conduct close visual inspection. But the other area, usually it is difficult to access. So you use the binocular and do the remote inspection, remote visual inspection from the distance. But this is kind of yearly inspection. And this is using the corridor. And it is only watching this is pedestrian corridor, but you can also monitor the carriageway from the corridor. And this is for this is Moachi-Otsunda Bridge, but you can easily access to the around the abutment, or I think even here you can access easily. So use the ladder in this kind of area. And for the principal inspection, the detailed inspection will be conducted, and this is what to observe. So for the superstructure, girder deck, so all kind of main structure, also accessories, of course pavement, drainage, and lighting system, also lighting system or road sign have to be checked. And so we classified in 3 categories by the area. And for the bridge surface and the abutment surrounding, it's same as the annual inspection, like that. And for the category 2, bridge girder end area, so this area is very important. So this one is the bridge inspection vehicle and inspection corridor can be used to check. And also we recommend to monitor not only the around the abutment or on the pier, but you can use the BIB. So we recommend to also mobilize the BIB for at least one span from the girder end. And this is just a little bit detail, but for the Mutezawa Moachi Bridge, there's a inspection corridor here. So you cannot set the inspection vehicle on left lane because the length of the arm is not enough, and you cannot ascend this kind of deck this side. So please only set the right side and use the deck, inspection deck like this. So in the manual, this kind of thing is mentioned. And also in the manual, we also explain how to set the ladder, because usually this kind of ladder is removed, and there's a two set of the ladder, and you have to put these ladder anytime you want to access to the inspection corridor like this. So please keep this, the two set of this, and set whenever you want to go down and use the inspection corridor for inspection. So in the manual, how to set this extension ladder to here is explained. And the category 3 is underside of the bridge. So there's a lot of span. So it is not efficient to use the BIB for all the piers, the girders. So we propose to use the boat to monitor the girders on the river like this, and use the at least the 8-time magnification binocular to watch out the pier girder. This is the actual photo using the certain binocular. So I think it is very useful and enough to monitor and observe the girder from the boat like this. And this is the last part of my explanation. And in the manual, in the last, the recommendation for future maintenance is mentioned. Actually, initially, on the girder, the surface of the girder is painted, but the inside of girder is not painted. It's just a pure concrete. Concrete surface is not painted due to the budget restriction. But so far it is okay, because usually salted air comes from hit the outside girder, and inside the girder is usually not affected by the salty air. But in the long term, if the girder is damaged or deteriorated, I would like you to apply the paint in certain timing. And also, this is for the operation of the maintenance. And because on the girder, we cannot see where is the pier. In downside, we don't know, because it is continuous bridge. So, of course, if there's a joint, we know there's a pier below. There's a pier, but we don't know where is a pier because there's no joint for continuous bridge. So, for our experience, we put this kind of ID number. This is the ID number on the bridge. So we understand which is end of the girder, like this. And this one was set during the construction by contractor. It means it is over the pier 1, but there's no joint. So This kind of thing is very important. So we recommend to put some kind of ID number on the bridge to do the maintenance. So finally, same as the Nissan already explained about the slope maintenance manual, but there's another book for the bridges for this empowered long span bridges, and contents like that, the bridge outline and design concept. So most of the part is telling about the design concept, but also adding how to do the inspection. And yes, and then finally there's a recommendation. Okay, this is finish of my presentation. Thank you so much.
Thank you. Thank you for the elaborate presentations. I will now start questions from this side so that I don't, these guys can prepare. We start from this side. Any question? You are satisfied? Okay, yes, there, the roaming mic.
I've not seen the manuals, but I was wondering, in a scenario where,
maybe give her this one.
I've not seen the manuals, but I was wondering, in a scenario where you're operating in an environment where funding is constrained, and you've done your monitoring and identified the defects, have you captured in the manuals sort of like quantitative risk ranking framework or decision matrix that can guide you on which interventions to prioritize? Suppose you do not have enough money, or is the decision left to the engineering judgment?
So is it about repair or something? If we find damage, and when to fix and how to fix, like that? Are you asking that one? Is it correct?
Yeah, I'm asking, suppose you identify different defects.
Okay.
Yeah, you've done your inspection and monitoring.
Okay.
Let's say maybe when you're maintaining the slopes.
Okay, slopes?
Yeah.
Oh, okay. but this is a bridge, but it's the same manner. But actually, this one is very much referred to JICA project. So basic thing is proposed by JICA, Technical Cooperation Project. And they developed a lot of manuals to tell this kind of strategy. So in this manual, we just mention the specific things to empowered bridges, because the structure is very specific. But maybe the damage of the structure is very same, even it is a big bridge, damage and what to do must be the same. So in other case, we refer to the basic manual developed by JICA project.
Okay, then question number 2.
Okay.
The manuals provide guidance for maintenance of bridges and even slopes after construction. That is after completion of the project. So while you're preparing the manuals, did you identify any recurring design and construction shortcomings that, if addressed at the project preparation stage, could significantly reduce the need for maintenance?
Oh, I see. Because our mission was the support for maintenance, but we joined also in the design stage, and we did some advice for considering the maintenance. So, for example, that's why there's an inspection corridor is set beforehand, and that was result of our advisory. If there's no corridor, it is very difficult to do the inspection after the completion. So in design stage, we advised to set the inspection corridor like that. So we did not so many things, but we did some advisory or give the comment at the design, and it is this bridge is result of our advisory.
Thank you, Engineer, for those questions. I think on your issue of identification of defects and how to address, you appreciate Dr. Kawakami indicated the levels through which we do the inspections. One, immediately post-construction, you are meant to do a baseline inspection, just to establish the condition of your structure. And of course, she identified the features that you will need to look at, the approaches to the bridges, the bearings, the joints, and including the street lights, which are the sections susceptible to some of the perennial defects. And then even at inspections, we have the performance-based, which is ideally continuous, because like in Kenha, we have the annual road inventory and condition survey. So when you're doing the annual road inventory and condition survey, is the time you also meant to be doing your annual bridge inspection. And you take very keen interest on some of the movable parts, like the bearings, the joints, and the approaches. Of course, with your inspections, whether routine or principal, and the principal is where we have cascaded it to 5-year standard, but depending on the quality of materials that has been used, this one for the MPAD has now been even proposed for 10 years, where you now use the bridge inspection vehicles, not just inspect the bearings and the joints, but including the girders and checking them, whether you're using the boat or you're using the bridge inspection vehicles, but you make sure that you get as much detail as possible. But in terms of maintenance, I think what she indicated first is the quality of installations that are used, especially for bearings and the joints, so that the joints, if not properly taken, then they affect the operations of the bridge. And that is why it is part of the PBC works, ensuring that the silt is removed on a regular basis, just to ensure that the movement of the bridge is concerned. And then the last issue that you have raised on any issue that may require attention at design phase to reduce the defects or damage, I believe that is why the manuals has not just concentrated on maintenance, but they have cast themselves back on the design. And if you looked at, say, the one presented by Nishi-san, he indicated that at the planning phase and design, especially for slopes, your attention should be drawn especially to the geological features, because they determine the stability of the slope. And even when it comes to the bridge, the choice of standard and materials that you're going to use for some of these parts. Remember how she has belabored to give us the issue of the piles, how you take care of corrosion, what design interventions you even need to take up, even if you are doing piles, and the corrosion and the moments of that. So the choice of materials and the design standards and principles really affect the quality of the product that you are going to have. So yes, it is true you have not seen, and that is why we are here, and the manuals are going to be cast. But remember what Nish is said, that however much you take care of design, however much you take care of construction, maintenance is still important, and that is why we have to continuously do inspections. Remember, you use the drone, which do not just inspect our corridor, but also inspects even the corridor adjacent to us. And that is what has identified the about 300 meters that is interlinking between Kenha and the KAA land, where we have the sinkholes and the irregularities. And I believe it is the interactions which have also even made KAA to take interventions in addressing even the challenges that they are facing. But it is good you have raised that, and we are going to share the manuals. Any other, so that I don't lock anybody here? Okay. We come in the middle here. Yes, engineer.
I'm impressed by the kind of innovation that has gone into the project. Maybe the presenter can just shed light on the role of artificial intelligence in bridge maintenance with regards to collection of data, collecting of this data, analyzing data, and even in reinforcement of early warning systems. Is there a component of artificial intelligence? Thank you.
Yeah, it is very new technology, and in Japan also we're trying to use, but seeing the believing, so that the first priority is watch out by human eye. And maybe if we find a lot of damages, it is case in Japan, we find a lot of damage because bridge is very old. Like we find 10,000 damages in a year in my company, in my highway. But we have to give the grade for 10,000 damages. In that case, we try to use the AI to do the judgment because there's a lot of similar damage, and the AI can understand this one is rank A, B, C or something. But first of all, we have to find the damage. But in that area, I believe that still it is rely on the engineer's eye and the engineer's knowledge. And after that, maybe we can use AI.
Thank you. I'm coming here. Any question? Any comment? Any concern? They look satisfied. Here? Yes, Mr. Opio from Kenyatta University.
Thank you for a good speech and good explanation. However, I've got 3 questions, especially on the design concept. One, the bridge is designed for 120 years and above. Now, we know the coastal region has got an issue with premature deterioration of reinforced concrete or rebars. So what measures did you put in place as far as the cement used or you commended is concerned, 1, 2, the class of concrete and the rebars? Did you use special ones or just use the normal, materials we have? That's question 1. Question 2 is, I saw the bridge is a multi-span bridge, continuous girders. Now I'm taking the worst case scenario. Supposing a rogue boat, comes and knocks one of the girders, what did you put something in place on the road path as far as so that we don't have progressive collapse of subsequent girders? Lastly, is on the street lighting vandalism. I know it's very prevalent. Most of the street lights are taken and which materials did you or do you recommend that are not palatable or good for scrap dealers out there so that we stop some of these menace of street or furniture vandalism?
Vandalism, yeah, okay.
Yeah,
Okay,
vandalism
okay.
of street materials.
Okay,
Thank you.
Okay. For the design, can I ask you? But I believe that in the coastal region, but we didn't use the special concrete. Is it a special concrete here, or is it a normal concrete is used? Okay. Yeah.
Or in this very auditorium, we had the launch. We hope they are going to complement the existing guidance that we have in our manuals, such as the Road Design Manual 2 on hydrology and drainage, Road Design Manual number 4 on bridge and culvert design, retaining and reinforced field structures, Road Design Manual number 5 on pavement condition survey, maintenance, rehabilitation, and overlay design. While the road design manuals guide the designs and development of infrastructure, the slope maintenance manual and bridge maintenance manual strengthen the next critical stage, or a very practical way of inspection, maintaining, protecting, and extending the service life of the assets that we have. In today's forum, we focus particularly, the focus has been significant as it marks also an important milestone in the efforts to strengthen our infrastructure asset management through formal presentation of these manuals. Now, these manuals are also closely aligned to Kenya's core mandate of developing, rehabilitating, and maintaining our national road network. And as an authority, our responsibility does not end with construction of roads. We are looking at sustainable infrastructure. We must ensure, therefore, that these assets are properly managed, regularly inspected, and maintained in a safe and reliable and sustainable condition throughout the life of those projects. Now, although the manuals arise from MPAD experience, which is really, really critical, the issues they address are not limited to one project corridor. Challenges such as slope instability, erosion, drainage failure, bridge deterioration, structural defects of various parts of our national road network are highlighted in these manuals, and therefore the value lies in providing a more standardized, preventive, and risk-based approach to managing similar assets of the authority. Now, these manuals have come also at a time when road infrastructure is increasingly exposed to the issues of climate change, including more intense rainfall, flooding, erosion, and slope failures. And they will support Kenya's efforts to build and maintain a climate-resilient infrastructure by promoting early identification of these risks and preventive action, and also better life cycle asset management for our infrastructure. Now, a call to action for us is to focus beyond receiving these manuals, because the value of these manuals can only be realized if we apply them. Now, they should guide our work for our maintenance teams, our bridge engineers, our regional directors, our road asset management teams, our safety teams, the environmental teams, our consultants, and all our practitioners who are supervising and overseeing our infrastructure. As a Planning and Research and Compliance Directorate, our role is to support this transition by promoting evidence-based planning, strengthening the institution learning, and encouraging compliance with approved standards and procedures. And I want to call everybody to ensure that this manual should not remain just on our shelves. Let us see them on our desks. Let us use it more and more. And we'll continue to support. So let us prioritize how we inspect our facilities, how we plan, how we prioritize, how we implement, how we monitor, and how we improve our maintenance across our network. So with those very many remarks, allow me to take this opportunity to invite our Director General sitting in today for the substantive DG, Engineer Gakuru, to come and make his remarks on behalf of the DG and also carry out the next step. Thank you and good afternoon, everybody.
Thank you very much, Engineer Cherono, Director PRC. Good afternoon, everyone. Yes, it was a very great presentation from Nishi-san and Dr. Yes. Thank you for the correction. So we appreciate your executive presentation of the slope and bridge maintenance manual. And I would like to request that we do a good applauding for that presentation to both, and we'll do the factorial way. I will request that we do a 3 factorial. Who doesn't know the factorial? Can it be demonstrated? We'll do a 3 factorial. 1, 2, 3, 1, 2, 1. Let us start. Thank you very much. I had earlier on said about our engagement with the government of Japan and the JICA, and Daktari, my neighbor here, made the confirmation that the engagement actually started in 1963. And we have had a lot of projects in various sectors, in health, in education. You know the Jomo Kenyatta University of Agriculture, which has produced many engineers by now. We have engagement in power or energy and agriculture and other many sectors. So I just wanted to re-emphasize that we appreciate, we don't take it for granted, the engagements that we have had with the government of Japan and through JICA, because JICA has come also in a big way, strongly supporting the transportation sector. We have roads and bridges, major ones, done under that program. One take home from that presentation was that we have to engage, that these manuals are not only for Kenha, they are for beyond the road sector. We have to work with other sectors of the government because, for instance, the slope stability is influenced by many other factors that are not only impacted by road construction. So we have to engage people in agriculture. We have to engage people in not only transportation, but even in energy, where we affect the stabilities of our lands that are adjacent to the infrastructure that we are doing. On bridges, yes, we have seen there is need for a technical support in terms of capacity, in terms of training, in terms of equipment. We are very much aware of the equipment we are using now, doing the analysis and picking data on our bridges may be not adequate in future, because we are really getting to a bigger infrastructure in bridges. So we are asking that as we continue with the cooperation with the JICA, we look at a way of enhancing the capacity in equipment and technical know-how. With that, allow me to verbatimly lead the message of the Director General, KENHA. The Chief Engineer Materials, development partners, consultants, contractors, engineers and technical experts, KENHA staff, KERA, KURA staff, our colleagues and stakeholders, ladies and gentlemen, good afternoon. It gives me great pleasure to welcome you all to the 9th edition of the KENHA Quarterly Knowledge Sharing Forum. I am delighted to see both the participants gathered in the Barabara Plaza Auditorium and those joining us through the virtual connection from different parts of the country. Today's forum is particularly significant as it focuses on critical aspects of infrastructure sustainability, the maintenance of slopes and bridge structures, and marks the formal launch of the Slope Maintenance Manual and Bridge Maintenance Manual, developed under the Mombasa Ports Road Development Project, specifically the Mombasa Southern Bypass, commonly known as the Nongo-Kudu Bypass. Ladies and gentlemen, as an authority mandated to develop, manage, rehabilitate, and maintain the National Trunk Road Network, we recognize that the value of infrastructure is not measured solely by the construction, but by its ability to safely and efficiently serve generations of users throughout its design life. Across Kenya and globally, road infrastructure is increasingly exposed to environmental challenges. Climate change has intensified the frequency and severity of extreme weather events, resulting in increased cases of erosion, slope instability, flooding scar, and structural deterioration of bridges and associated assets. At the same time, growing environmental compliance requirements and constrained maintenance resources continue to place pressure on infrastructure managers. These challenges demand a shift from reactive maintenance approaches to proactive, risk-based, and asset-focused management practices. Historically, one of the gaps identified in the management of complex highway infrastructure has been the absence of standardized and comprehensive maintenance guidance for specialized assets such as engineered slopes and bridge structures. Consequently, maintenance interventions have been undertaken after problems become visible, leading to higher costs, service disruptions, and increased risks to road users. The manuals being launched today present a major milestone in addressing this challenge. The Slope Maintenance Manual provides practical guidance on the inspection, monitoring, maintenance, and rehabilitation of slope protection systems, drainage structures, retaining walls, and other geotechnical components critical to highway safety and reliance. Similarly, the Bridge Maintenance Manual establishes structured procedures for bridge inspections, condition assessments, maintenance planning, preventative interventions and asset performance monitoring throughout the bridge life cycle. Together, these manuals provide a standard framework that will support improved infrastructure safety and reliability, enhance resilience against climate-related risks, better asset preservation and life cycle management, more efficient allocation of maintenance resources, consistent inspection and reporting practices, and reduced long-term maintenance and rehabilitation costs. Ladies and gentlemen, the development of these manuals aligns closely with KENHA's strategic plan and our commitment to strengthening asset management practices across the national highway network. They also support our broader objective of building a sustainable, resilient, and efficient road transport system that contributes to national development and economic growth. Dongokudu bypass is a flagship infrastructure investment that plays a strategic role in enhancing connectivity to the Port of Mombasa, facilitating trade, supporting tourism, and unlocking economic opportunities within the coast region and beyond. Protecting such investments through effective maintenance is therefore not optional, it is essential. I commend the project financier, JICA Office Kenya, MPAD project team, the Directorate of Development, the Directorate of Planning, Research and Compliance Directorate in KENHA, the Directors of Maintenance, the consultants Katahira, Engineers International, the contractor Fujita Corporation, and all stakeholders who have contributed to the preparation of these manuals and the organization of this forum. I also wish to emphasize that the success of these manuals will not be measured by their publication alone, but by their adoption and implementation. I therefore encourage all technical teams, regional offices, project managers, and maintenance personnel to embrace the guidance provided and integrate it into routine operations and maintenance activities. Knowledge sharing is one of the most powerful tools for institutional growth and continuous improvement. Through forums such as this, we create opportunities to learn from experience, exchange best practices, and strengthen our collective capacity to manage increasingly complex infrastructure assets. As we deliberate today, I encourage participants to engage actively, share insights openly, and identify practical ways of applying the lessons from these manuals across our projects and networks. In closing, I wish to thank all participants for taking the time to join this important forum. Your presence demonstrates our shared commitment to engineering excellence, infrastructure sustainability, and service delivery to the Republic of Kenya. At that point, please allow me to do some alteration. Where I have mentioned about the lounge, you'll say it's official receiving of the manuals, because I believe we will be doing a more elaborate launch for these manuals. That is our opinion, and if it is agreeable, we proceed that way. So Engineer Carrot, you can guide us while we proceed beyond there. Thank you very much.
Just. I think I'm well guided, and so that I redeem myself, like the director indicated, let's just take a bit of a few minutes. We shall have issuance of certificates to the teams that have brought us this far, after which there will be the official receipt of the manuals, and then we will call it a day. So without much ado, allow me to take this opportunity to invite the following persons to receive the certificates. I think I will request the director. I will start by asking the director maintenance to come and issue the following certificates. So the director maintenance, please come up front. You know yourself, director maintenance. Joel Korir. Joel Korir is he present? Yes, Joel Korir works for the JICA office, and they were very instrumental in the development and realization of these manuals. You will receive it from the maybe you stand here so that you are captured properly. Yes. Director, you will also give this one to Frida Jebor. Is Frida Jebor with us? Yes, Frida Jebor. The citation is that awarded for your coordination in the development of the slope and bridge maintenance manuals 2026. May I do, thank you so much. I want to invite the director PRC to also issue the certificate to the following: Ephraim Magana Rukaria, then Moses Okwiri to follow. Moses Okwiri, then Eustace Mutea, Engineer Mutea. The next person is Yasuyoshi Nakashima. Is Yasuyoshi Nakashima? You will pick on his behalf. Now that he is here, I want to request Nishi-san, maybe you don't go. Sorry. Your certificate. Yes, yes. To Motohiko ni Shibayashi. Then we have Dr. Yoriko Kawakami. She's called Mukami in Kenya. Yes. Engineer Samuel Ogege will pick for Engineer Ngala, pick for Engineer Ogege. There is also one here to Engineer Clarence Carrot. Then I want to request that director, you also do a presentation to certificate to the Director of Development, Engineer Henry Gakuru, for being the Chief Project Coordinator. Yeah. And receive a certificate that is awarded, and the citation is awarded for your financial contribution to the MPAD project. All those who even received plus JICA office, please, let's just come up front so that we make it a colorful reception of the manuals. Let's be up here. Maybe I will also request Engineer Teresia and the other teams who are in JICA to come up front, because it's also your time to shine. You have been sitting so much. Kurgat and the team, those who are in the JICA, will be this side as we give the manuals. Yes. Yes. Yeah. This marks the official receiving of the bridge and slope maintenance manuals. They are in 2 volumes. There's one specifically for bridges, and there's another one specifically for slopes. So it's my singular pleasure to ask the DG perhaps to just shake hands with the consultant as a sign of receipt, as the team from the Katahira engineers hands over the manuals on behalf of JICA to Kenha. Thank you. And maybe as a sign of goodwill, shake hands across. Yes. These teams must shake hands with the other team. Yes. 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 Yeah.
And also you've done very well.
Okay, thank you so much. I think that marks the end of our session today. But allow me, even as we come to the close or the final prayers, to recognize those who actually joined us in this forum. I know we were running, we are trying to take care of time, but what we noted is that there was quite a bit of numbers that came with us, and we appreciate you. I just want to read those who are present. Of course, we have the consultants from Katahira Engineers, and of course the experts from Hanshin Expressway. We want to appreciate you in your presence. We are also represented here by those experts in the bridge maintenance consultancy, JICA, Bridge Maintenance Consultancy Services. We also have the State Department for Roads. We recognize your presence. We were also informed that we have representation from Kenya Roads Board. We recognize your presence. We have Kenyatta University. We thank you so much for coming. We have Koei Africa, or Nippon Koei. Your presence is valuable. We have Raseka having their representation in this place. You have Rocks Engineering. And in addition to that, I have also been reliably informed that we have a representation from Jomo Kenyatta University of Agriculture and Technology. We appreciate your presence. We have Kenyatta Universities, which I've stated, and we also have Dedan Kimathi University. Your close collaboration and cooperation with us is so well appreciated. With those many, many remarks, it is now my pleasure to indicate that your sitting here has earned you lunch. Why don't you clap? The only problem I have is how to handle my virtual audience. But I will also tell you that having sat with us for over 3 hours, you have also earned lunch, only perhaps it will be at your cost. But for those who are here, Director Development is going to sort you out. So after the final prayers, I wish to request that we will will be guided up in the place where we shall have our lunch, and it will mark the end of the knowledge sharing forum. We believe the next time we meet, we shall also be with JICA as we discuss Mombasa Gate Bridge. So where is Engineer Teresia? Engineer Teresia is our priest for the food today. Engineer, pray for us for journey masses, and also pray for food. Yeah, I'm told there is a QR code being scanned. It's good that you give us feedback on how to improve, because continuous improvement is the only room that never gets full. So please don't forget to take a short survey and give us improvements.
May we arise and pray? Lord Jesus, we come before you. We want to thank you for a successful event, for a successful launch of these manuals. We want to pray that you are going to help us in our daily work. As we go to lunch, we want to pray that the meals we partake are going to be useful to our bodies and to be able to serve you and to serve humankind. In Jesus' name we pray.